Okay, so welcome back to another video. So in today's video, we have the following math contest problem that was proposed in Romania from the 1959 International Math Olympiad, which is the second problem. For what values of x is the square root of x plus the square root of 2x minus 1 plus the square root of x minus the square root of 2x minus 1 equals a, given that part A, capital A is equal to the square root of 2, part B, A is equal to 2, and part C, A is equal to 2, where only non-negative real numbers are admitted for square roots. So this is a very interesting math contest problem. So basically this whole, the way to approach this is it's mainly just using just algebra. There's really no calculus involved, which is kind of nice. And there's actually some properties with the whole square root function as itself, where we're going to be analyzing a couple cases and then determining whether what kind of x values would actually satisfy the following solutions with these specific conditions. So now to start off this video, there's one thing to analyze, and that it's the square roots. That's to imply that x, I'll write this first, square roots imply that x is actually greater than or equal to 1/2. As you can see with the square root of 2x minus 1, if you solve for your x for 0, because there's no such thing as a negative square root, because otherwise you'll be dealing with, imaginary numbers, but that's not the whole point. And even especially where we're dealing with non-negative real numbers. So this is one fact to establish. X is supposed to be greater than or equal to 2. So now from here, what I'm going to do is I'm actually going to square A. And so this means that we're actually going to be performing the binomial method. So we have a square is equal to, and I'll just save the work, and we have that this is just x plus the square root of 2x minus 1, then plus 2 multiply with the square root of x plus the square root of 2x minus 1, and of course multiply that with the product of the square root of x minus the square root of 2x minus 1, and now lastly add that with x minus the square root of 2x minus 1. So that's our a square. And now if we can continue simplifying some stuff out. So let's see, we can combine the x's, so we have a 2x. And now we add this with, of course, this is still going to remain the same. So this will be 2 times the square root of x plus square root of 2x minus 1. Then, of course, we multiply that with the square root of x minus the square root of 2x minus 1. And that's it. Since now we have square root of 2x minus 1 here and here, they cancel each other out, so we're good from there. And now the next step is we can continue furthering simplifying this out. So I can establish that we can write this as a difference of squares. So we know that a plus b multiplied with a minus b, that's simply just equal to a square minus b square. So that's what I'm going to do for here to manipulate this. So this asterisk, I'm just going to follow and put it over here as to mark specifically for the 2 times the products of the square roots. So that way that gives us, so just rewrite this. So x plus square root of 2x minus 1. Then we multiply this with x minus the square root of 2x minus 1. And so that will just be equal to, so of course I can actually, there be multiply, or the exponents is 1/2, so I can actually rewrite that. And of course we write this as our exponent, so this will be x plus the square root of 2x minus 1, then multiply with x minus the square root of 2x minus 1, and then that's to the power 1 over 2. And we can continue furthering, simplifying forward, that this will be, just use the FOIL method, so this will just be x squared, then minus x, then plus, so that'll just cancel each other out. And now the square roots times square roots, that'll cancel each other out, so we're just left with plus 2x minus, actually that's supposed to be a minus. That's supposed to be a minus over here. Minus 2x and then plus 1. And then to the power 1/2. And just rewrite this as x squared minus 2x plus 1. And now I just replace this back from here. So of course this will just be 2x plus 2 times the square root of x squared minus 2x plus 1. Now I can just factor out the 2. So this will be 2 times and then x plus the square root of x squared minus 2x plus 1. Actually, now I can actually just write this as difference of squares. So really, I can actually write this as x minus 1 square. And now the property we want to use next is, and people tend to forget this too, because obviously you know that square roots, you need to consider both the positive and the negatives, but there's actually a little generalization you can easily use for this. So you use the property that, for example, we say the square root of x, right? The square root of x squared is actually just equal to the absolute value of x. And it would make sense because absolute values, you consider both positive and negative values, just like what you do with square roots as well. So that's one justification that you need to realize and that we're gonna actually use going forward. And so now if we do this, so now we would have a square is equal to 2 times x and then plus, now just replace this with, it will be the absolute value of x minus 1. And now the last thing to do is now we actually have to compare 2 cases since we're dealing with absolute values. So now the first case I want to analyze is we need to consider x being less than or equal to 1. So x is greater than or equal to 1, or less than, excuse me. That means if x is less than or equal to 1, then that would have to mean the absolute value of x minus 1 is equal to 1 minus x, right? And if we do this, we just replace from our absolute value x minus 1 with 1 minus x. Then we would have 2 times x plus 1 minus x. And so that will just equal 2, and that will be equal to a square, okay? And would you look at that, if you actually do take the square root of both sides, then you would get that part A of the question is actually valid for specifically in the interval between the closed interval from 1/2 to 1, as you can see. So less than 1, then that means it's in this closed interval for part A. So I'm going to box this first answer saying that this justifies part A of our solution. And now the next thing is we have to consider part 2. So, well, case 2 specifically. And that is case 2 is, this is when x is strictly greater than 1. So if that's the case, so if x is strictly greater than 1, then that means the absolute value of x minus 1 is, well, just equal to just x minus 1. And now if we do the substitution, then there'd be 2 times x plus, so that would be x minus 1. And if we do the simplification, we would get 4x minus 2. 4x minus 2 is equal to a square. And continuing forward, we would have 4x is equal to a square plus 2. And keep going further. If we want to solve for x, you'll get that x is equal to, and I'm just skipping the steps from here. You'll get that further. It will be a squared plus 2 divided by 4. But as you can see from here, it's actually strictly, and we say that x is strictly greater than 1, so we could actually use that inequality over here. But if we were to continue solving forward for a, so that would mean a squared plus 2 is strictly greater than 4, but that would have to imply that a square is strictly greater than 2. So what does this imply? Because part B, we have that a is equal to 1, but that's not possible. So this would mean that a square has to be greater than or equal to 2. And so part B, I'm just gonna write over here. So that means part B is that there are no solutions that satisfies the following, since we must have a squared be strictly greater than or, not strictly greater than, but greater than or equal to 4, or excuse me, greater than or equal to 2. Sorry about that. And now, keep going further, we could see part C. When we have that a is equal to 2, then that will have to be that here, I'll write part C. So when A is equal to 2, then that means A squared is equal to 4. And so that means, of course, you can, now if you actually solve from further here, then you would get that X has to equal 3 over 2, since it falls under. And there we have it. We have the following solutions. We have that part C, it had to be X is equal to 3 over 2. And then part B is that there is no solutions. And that completes the proof. We have the following solutions that satisfy these 3 givens, like so. Okay, so yeah, that's pretty cool if you ask me.